Hey everyone, today we're going to be talking about linear inequalities. Linear inequalities are very similar to linear equations, except that now we're dealing with that inequality symbol. And my phone's going off. So that's what we're going to be talking about today. So that's the biggest difference. We've been dealing with linear equations, and now we're dealing with linear inequalities, where we have two variables, and we're going to talk about all the different possibilities that inequalities provide for us. But the first thing we're going to do is we're going to see if these solutions, these points, are a solution to this inequality. So I'm going to figure that out just by plugging in the x and y and see if it comes up with a true or an untrue statement. So again, here's my x, here's my y, and I'm just going to plug that into my first linear inequality here. So in place of y, I'm going to replace that with 2. My inequality greater than is going to stay where it is. Instead of x, I'm going to plug in 1, and the minus 3 comes along for the ride. 1 minus 3, we're cleaning this up, is -2, and I'm left with my endpoint there, and 2 is greater than -2. So that is a true statement. So this is a solution. This point 1, 2 is a solution to this inequality. It's going to make a little bit more sense once we start graphing these, but I thought this would be good practice in just plugging in random points and seeing if it's a solution. Let's do the same thing with the same inequality, but we're going to use the point 5, 1. Remember, this is x, this is y. I'm going to plug in 1 for y is greater than x. In this case, it's 5, plugging in 5 for x, minus 3. Cleaning this up, 1 is greater than 2. That is not a true solution. 1 is not greater than 2. 1 is less than 2. So this is not true. So this is not a solution. This is 5, 1 is not a solution to this particular inequality. We're now going to move on, and we're actually going to start graphing these inequalities. Now, let's okay. Now, let's just jump right ahead. We'll talk about the line and the shading in a second. But what's nice about graphing inequalities is it's the same setup as when we're graphing equations. We want our inequality to be in y equals mx plus b form, in slope-intercept form, so that we can pull out the slope and we can pull out the y-intercept and graph our equation. So let's do this. So let's just pretend that this is in y equals mx plus b form, and we're going to deal with that inequality in a second. But first, we need to graph that line. So in this first one over here, our y-intercept is -1, and our slope is 2, but we know that we want to turn that into a fraction, so it's going to be 2 over 1. And now we're ready to graph. Our y-intercept is -1, which starts down here. I'm just going to use red. And our slope is +2 over 1. So 1, 2, 1, down 2 over 1, and on and on. Now, so those are some of the points, and now it's going to come to my line. Now, here's where it gets a little bit different than solving for linear inequalities, or graphing rather. When I am left, when I have a greater than or less than symbol, I'm going to leave this as a dotted line, and this is going to be key to our inequalities. So instead of just graphing a solid line, I want to make sure that that line with all of my points is a dotted line. I'm going to draw my arrows. So I've graphed it, a little off there, but that's okay. Now comes the shading part. And when I'm shading, now that I'm dealing with inequalities, I'm dealing with a variety of solutions, not just discrete set solutions, like this one, this one, this one, this one would be solutions if it was an equation. Instead, I'm dealing with a variety of solutions. So I'm actually going to start shading either above or below the line to show all of the solutions for this particular inequality. And as I say up here, I'm either going to shade above or below. But when I'm dealing with a greater than symbol, greater than or equal to, I'm going to shade above the line. So graphing inequalities has a lot to do with shading after we draw our line in y equals mx plus b form. So on and on, all of this shading above the line, all of these points are going to be solutions to this inequality. And I could just pick them at random here. That point, that point, that point, the x and y, if I plug that back into the inequality, I will get a true statement. Nothing down here below the line will work for that inequality. Let's move on to the next. So again, this is written in y equals mx plus b form. My slope and my y-intercept I need to pull out. My y-intercept is going to be +3. My slope is going to be -2/1. And I have all the information I need to create that line. I'm going to do it in green this time. So here's my y-intercept 1, 2, 3. And my slope, I'm going to have a negative slope. So it's going to be going downwards like this. And I'm going to go rise 2/1. 1, 2/1, 1, 2/1, 1, 2/1. Okay, so there's my line. And I want it now, I need to figure out if it's going to be dotted or solid. Now, as I say here, whenever I'm dealing with a greater than or equal to or less than or equal to, I'm going to have a solid line. So over here, I dealt with the dotted line, but now I'm going to make that line solid. So I'm actually going to just draw a regular line, which is what we're used to doing for equations. And there's my solid line with my arrows. So I got my solid line. Now I need to figure out, am I going to shade above or below? And as I put out here, if it's less than or equal to, I'm going to be shading below the line. So that's what I'm dealing with here, a less than or equal to, which matches this. So I'm shading below the line. And that's it. And all of the shading, it would go on forever in theory. All of these are solutions to this inequality. Nothing above the line will work. Everything below the line will work. So if I take any of these points, x, y, and plug it back into the inequality, I will get a true statement showing that everything below the line is a solution to our inequality. That's it for now. Thanks for watching.